Hello everyone and welcome back. My name is Mr. Kowalt, and in this video I'm going to show you how to calculate the standard change in free energy for a stepwise reaction. And so what that means is that you've got one reaction, you're trying to find the standard Gibbs free energy change, and you have other reactions that you know the standard free energy of those reactions, and you can manipulate those equations and add them together to get the target equation. And then you can follow kind of Hess's law type strategy where you can then add up the free energies of the reactants that gave you that resulting reaction. So let me go ahead and show in this example here. So here, this is our target equation. This is a 3-carbon solid plus 4 H2 gas gives us propane gas. And we want to know what the standard free energy change is going to be for this reaction. And they give us these 3 reactions, to which we do know the standard free energy changes for them. So just like with Hess's law, whatever we do to the equation, we've got to do that to the free energy. So if we reverse the equation, then we got to change the sign of the free energy. If we multiply by a certain factor, then we got to multiply that by the same factor as well. And then if we add up the equations, then we have to add up the free energies for those reactions. Okay, so this is our target. So we want carbon solid as a reactant, and we want hydrogen gas as a reactant. So we're going to look at the equations here. We want C3H8 as a product, and here we have it as a reactant. So what we're going to have to do is we're going to have to reverse it. So we'll have 3 CO2 gas plus 4 H2O gas, right? And then that's going to go to C3H8 gas plus 5 O2 gas, oxygen gas. Okay, so we reverse the reaction, so we have to change the sign to the free energy, the standard free energy. So then that's going to be the standard free energy of this reaction is going to be the positive value of that. So positive 2074 kilojoules. Okay, so now we have our propane on the right side. Here we have carbon as a reactant. We have it as a reactant, but we should have 3 carbons. So we're going to have to multiply everything by 3. So that will give us 3 carbons, 3 oxygens, and 3 carbon dioxides. And so what we'll have to do is we'll have to multiply this by 3 as well to get the new equation and the new delta G, the standard free energy change of the reaction. I'm going to cross this out since we don't need it anymore, and because we got the new equation down here, so that way we don't get confused. Okay, so the next thing we want is hydrogen. So we want water on this side, and we want hydrogen on this side. And notice that we have hydrogen on this, but we only have 2 hydrogen. We want to double check to make sure we don't have hydrogen anywhere else that we might add up, and it doesn't look like it. So what we're going to need to do is we're going to need to multiply everything by 2. So that means that we're going to multiply this by 2 to get 4. This will become 2, and then this will become 4 as well. And so now we have hydrogen as 4. Now we can cancel stuff out that we don't want to make sure that everything adds up. So when we add this up, right, when we add these equations up, we only want 3 carbon, 4 hydrogen gas, and 3 and the propane gas to be in our equation. Everything else you cancel out. So for example, oxygen here. So it looks like when we add these together, we have 5 oxygens here. So we need 5 oxygens as a product. So we have them here as a reactant. And look, we have 5 oxygen here as a product. So these 5 will cancel out with these 3 and these 2. Okay, so that gets rid of the oxygen. Notice we have carbon dioxide here. We don't have it here, so that should cancel out. So we have 3 carbon dioxide as a product. We want it 3 as a reactant, and here we have 3 as a reactant. So that'll cross out. And then lastly, we don't have water, but we have water here. So we have 4 water as a product, and we have 4 water as a reactant. So that will cancel out when we add it together. So the only things that are left is the 3 carbon, 4 hydrogen, and then we have the 1 C3H8, the propane. So when we add these equations together, we get 3CS solid plus 4 H2 gas is going to give us C3H8 gas. So since these 3 equations add up to this one, therefore the standard free energy, the standard free changes in free energy should add up to this one as well. So all we need to do is add these 3 together. So here, the standard free energy of this reaction is going to be equal to 3 times negative 394.4 plus this one here. Did I multiply? I did not multiply, so I forgot I should multiply. Because I multiplied this by 2, I need to multiply this by 2. So then we're going to add 2 times negative 457.1 plus, and then finally this one here is just going to be 2074, and then all of that added together should be equal to negative 23 kilojoules. So negative 23 kilojoules. So that is the standard change in free energy for this reaction here. And that's all that's to it. I hope this was helpful. I hope you enjoyed this video. If you like my videos, please like, share, subscribe, hit the notification bell, leave a comment down below. Thanks for joining me, and I'll see you next time.